In today's class, we are going to see a problem of solving particular integral when your right hand side is a trigonometric term, like only two cases, okay, for the trigonometric term. Either it can be a function of sine or a function of cos. Okay, so your differential equation, if I'm taking d square y by dt square plus 4y is equal to sine of 2. Okay, like previously, what you'll do is first you'll substitute d by dt is capital D. So it will be d square y plus 4y is equal to sine 2t. Next step is you'll take y common outside, sine 2t. So how do you write the particular integral is nothing but you'll write it as sine 2t divided by d square plus 4. Okay, so now case 2 where you have your right hand side as a function of sine. So it will be of the form sine 80 or it will be cos of 80. So here when you have your right hand side as a function of sine or a cos, how do you write the particular integral? The general form is, you can see here, it is sine 80, but here the substitution would be done for d square. For an exponential, the substitution was done for d, right? So here it will be a function of d square. Okay, so this can be, numerator can be sine 80 or cos of 80. So but the denominator, your substitution would be for d square. So what substitution you make here for d square is, it will be minus of a square. So when I'm writing itself, you can see that this minus is not for the whole of a square, but after finding your a square, then it should be multiplied with your minus. Okay, so here, coming to the problem, what I do is, I'll have it as sine of 2t. What is my d square here? My a square, d square is nothing but minus of a square. A is nothing but, it is the coefficient of t in the function. So here I have 2t. So t's coefficient is 2. Okay, so it will be d square is equal to minus of 2 square, which is equal to minus 4. Okay, so now when I substitute, I should get minus 4 plus 4. Okay, so when I get 0 to the denominator, what I have to do? I have to put t to the numerator, write the numerator, rest of it same as such. Now the denominator, what I have to do is, I have to differentiate it. So it will become 2d and differentiation of a constant is 0. Okay, so now since the right hand side is a sine function, my only substitution can be for d square. But here I have d. So what can I do is, I can take this d to the numerator. What is d? Actually, d is nothing but d by dt. Differentiation with respect to t. Okay, now what happens is, when I take it to the numerator part, it will be like t, it will be t by 2. Okay, this differentiation when it goes to the numerator will become integration with respect to t. Okay, so it will be sine 2t dt. Okay, you might be wondering, like this t is also a function of t, but why does this doesn't come under integration? Is the thing is that this t was brought inside for substitution. Like when the denominator became 0, this t was added inside. So in this case, t shouldn't be considered inside the integration. If it is normally present in your equation, this was your beginning equation, right? If here itself you had that t, it should be considered for integration. Now in between, since the denominator was 0, we multiplied by t. Okay, so in that case, this t shouldn't be considered for your integration. Okay, so now it will be t by 2. Integral of sine is nothing but minus cos 2t. Next, you have 2t again, a function. So that should be divided by 2. So overall, the answer would be t by minus t by 4 cos 2t. Okay, so this would be the particular integral.